So, hi everyone. Thanks for coming to the masterclass. Great to see so many people. I was actually expecting this to be a lot smaller today, so it's really good to see we've got a lot of people. Right, so yeah, my name's Rishi Supra. So I'm a consultant at a company called Altia. So we do data analytics, business intelligence, a lot of stuff with Azure, a lot of stuff with Microsoft. And I've been involved with these hacks for right since the beginning, actually. So I think this was hack 2, where one of the challenges from John on the A14 team was looking at how to project delivery using the P6 schedule data. So P6, if you haven't come across it, is an Oracle system for scheduling. So it's used very widely in the construction industry to look at how schedule data is presented. So really what we wanted to do with this was look at how we might be able to predict whether we're going to be able to deliver the program on time. Now, this was the kind of challenge. So we don't have this challenge this time, which is why it's a good idea to actually present it. So I'm not presenting a real challenge what we're doing this time, but it's going to be something that's quite relevant. So what we're going to do is utilize some past performance and calculate kind of how we can do it. So this was our team last time, so we did it back in 2019. And how could we calculate the confidence in achieving the future program? So let me show you some of the data that we've got with this. So hack 5, that was hack 4 data, P6 schedule data. And so what I want to try and do today actually is just show you how you might get started with working with some of this data using Power BI and where we can kind of go with it. So it's more an approach and methodology, and we'll do some of the data kind of cleansing and some of the data analysis. And then in a Mark session later, he'll look at some of the more advanced data visualization kind of techniques. As I say, we can go as advanced as we want with this today, as much as time allows. Whatever you want to do, if you want to look at how to do some more advanced things in here, we can pick it up afterwards. So the first thing is to kind of have a look at some of the data and have a look at what the guidance we've got. So really the first step on all of this is trying to understand some of the data and understand what it is you might be able to get out of it. So if we just have a look at some of this, so my machine's playing up a little bit, but we've got here for data date. So this is ASAT each data date. So ASAT each date. So it might link to extract date, but you might have different dates for extract date. So essentially it's for each cut of the data. So we've got for a project ID and an activity ID, location, and then we've got the name of the kind of activity. So this is looking at all the different activities. So against each data date, against each cut of the data, against each activity, we've got early finished. We've got an early finish date. So we've got some. The first thing to try and do with any of this data is to actually get a bit of a data dictionary to understand what those data fields mean. So they might not be obvious. And here, what we've got is some guidance around what this is. So these were the documents provided, and I'm hoping with all the challenges that you get, you will have some kind of indication as to what the data represents. So this is a little bit of background to it. So it's A14 from Cambridge to Huntingdon, and I don't know how this is last year, so I don't know how much they've progressed since then. But John can tell you, I'm sure, if you ask. And we've got some reference data here as well. So this is kind of location codes. So these are the codes that are in the data, and it's giving you a description and a description as to which section that is. So it's split into 6 sections, and these are the kind of sections on here for the A14. So that's quite useful, and we've also got activity codes. So again, activity codes is one of the fields in our data set. So we've got a description for each activity code, and then what it relates to. Does it relate to project overheads? Does it relate to indirect works? And so on, fencing. And so we've got that data, and then we've also got some guidance on program trend analysis. So this is where we start to get the description of some of these fields. So if we could look back on some of the data here, and our activities. So we've got data date, project ID, and in each of these we can kind of see project ID should be alias activity ID, location code, and that's what we've seen before with location code. Activity code, that's what we had for our reference data there. And then we've got actual finish date. So that's going to be an actual start, finish, or date is allocated. Otherwise, it's blank if it's not completed. We've then got a float. And the float here is going to be the amount of time an activity can be delayed without causing impact to the start and end date of the subsequent task. So we've got float in terms of how much slack we've got in the activity, in that task. And then we've got baseline finish date. So here we've got the date on which the activity is expected to be completed within the approved schedule baseline. And the baseline is your March 18 data. So at the data date, that's at March 18. If we filter for that, that's going to be your baseline, right? So that's the dates on there is what we take as our kind of our line in the sand for that as a reference point. And then also we've got obviously all the other data dates after that as well. And then we've got finish date variance, early finish date, late finish date. So here we've got the earliest possible point at which it may be completed and the latest point at which it could be completed. And then we've got the type. So we might want to filter out milestones in here. So this has got both milestones and activities. But again, we want to think about what it is that we want to do. Remaining early finish date and extract date. So we've got a bit of an understanding of some of the data. And actually what is a really good idea to do if you haven't already kind of got, especially if you haven't already got some fields, is to start to build your own little data dictionary to understand the data. So copy down all the fields. I was actually going to prepare an example, but we could do one kind of just very quickly on the fly. It's to look at all the fields you've got in your data set and then kind of give it an example value. So you've got field, and it doesn't have to do, we could give it an example value, and obviously here we need to format those properly. And here we can do a description. And here we can then copy in the description that we've got, say, from our data dictionary, our source, our Word document, whatever it is. And then we want to start to think about whether we need to use this or not, whether this is relevant. So start to put in some fields in terms of, are we going to use this used in a measure or calculation? Right, so how are we going to use this field? And one of the main exercises for this, and we'll come back to kind of how we can populate this, but one of the main exercises is to work out what you don't need. Because if you just try and bring in all of your data into Power BI or indeed into any other tool, it's more so, you've got performance issues potentially with bringing in huge volumes of data that you don't need, that you're not needed to analyze, and that has a performance impact. And also, it's in terms of analyzing it, you just get lost. So one of the main things to do is actually start with the smallest set of data you can for what you need to do. You can always add on more fields later on and do different types of analysis, but start with the minimum that you need. So actually try and keep the data as sparse as you can. And here used as a dimension, which is kind of a slice and dice field. So this is kind of one thing I suggest setting up as well initially, is to start analyzing the data and start just looking at, you can also do things on here like quality analysis. So percentage of values populated, right? And you can, again, if you're doing this in Excel, you can do something like just count the number of blanks or count the percentage where they're not blank. So we can do some things like that. So we can start to understand a bit of data quality, because if you've got a field, even though it might be really interesting and useful, if it's poor quality, that it's full of blanks, then it's not that useful to you, right? So start to look at some of the data and start to look at some of these. And then one of the first steps we need to do, and this is true for any kind of data analytics, is to really understand what you're trying to get out of the data. What are the questions that you need it to answer? So one of the things I've kind of done in a lot of my community examples is this kind of scoping template. So it's an idea of actually saying, right, let's focus on a specific audience for this report, for this data analytics solution, and let's look at the key questions they want to answer. So this particular person, ideally, so there's a few fields in here, I'll go through these, and ideally this should be, user audience should be someone specific. So when you're taking this back to your business, it should be someone that you're building this report for. what I see a lot is actually reports that try and cater, be all things to all people. And what ends up happening is no one really finds them that interesting because they're not that specific to what they're trying to do. And we see a lot of reports that have a very wide audience, and I've seen this with project reports as well. And once they start scaling out, you look at the usage metrics, and it's just the developers and one or two other people who are actually looking at the reports. And that's usually because they're not focused enough. So getting that focus right from the outset is really, really important. So we have user audience, and then we have so what are they particularly interested in? So this is for this example, right? So we're saying actually, let's take a step back. What is it they really want from this data? And, go and speak to John and say, look, John, what do you want from this data? Right? You're our customer in this example, and John will say, look, I really want to know whether actually the project is going to be completed on time or not, given our data. And for each section and overall. And if there are variances, I want to know where, and I want to know what stuff is coming up so I can go in and fix it. So that's kind of the main kind of problem statement. So then you come up with specific questions that you want to answer. So when is the baseline finish date for the project? How has this changed over time? What is our projected finish date, right? So let's come up with some date where we think we're actually going to finish the project based on whatever criteria we want to come up with, and what's that variance? And what's the progress complete for each section overall? So for some of you, we might be able to show this, for example, as an S-curve. So we can show the percentage complete over time. What proportion of activities are we completing? And how does this compare to previous scheduled cutoff dates? So we can use the historical data. We're probably most interested in the latest data date, i.e. where we are right now. How many activities have we got left? What percentage have we completed? But also we want to look at historically, how many did we plan to complete in that given week or month, whatever it is, and how many did we actually complete? Because that will tell you then actually where our slippage has occurred. We might still be catching up on a really bad month that we had last month or the month before, or we might be actually that we're on track. So these are the questions that we really want to know. And then we think about, right, for those questions, what are the KPIs and measures that could potentially answer this? So we want to look at the latest finish date, the number of completed activities, the percentage complete, which is going to be the number completed over the total number of activities. So we can start to think about some of those measures that we could put in here. And then what would we want to see them by? So we'd want to see it by data date. So we'd want to see for the latest data date and for previous ones. We'd want to see it by section, so by location, and by WS, activity type, activity code, things like that. So we can start to bring in some of these. And then we've got a kind of data points for what kind of data points would we need for this? A very high level description. Actually, we need the P6 activities that's showing this. So you don't do this activity without having ever looked at the data, but at the same time, you're not just trying to look at the data and say, how can I make this look pretty? What you're doing is starting with the business requirements and saying, actually, what do I need to do? I started looking at all of this stuff actually when I was going through this. I looked at activity analysis and a milestone, a resource. And the point is actually start with one thing and then actually start to look at what data you need for that. And as I said, what is actually important from this is more actually the data you don't need as well as the data you do. Because what we could do from here is then two things. Number one, we could start to do this idea of conceptual modeling. And what I'll do, let me open up a quick StarNet example. So the idea of this is that it's what you can start to do is look at what you've got around your measures and dimensions. So this is how you build a data model. So one of the things we can start to do is understand the data model we're going to need. And this data model for Power BI is really critical because it determines how your data is going to be structured. And again, what we're doing here is completely conceptual. So we're not starting with the tech and building data models, we're starting with the business requirements and the ideas. And we can go into something like this that says, okay, so here's what you've got in the middle, which is basically your measures. And these are the kind of measures that we identified. And then on each of these branches, we've got your dimensions, your things that you're going to slice and dice by. So in this case, it's a retail example. So we've got things like customer, product, and in here we've got then all of the different attributes that we want to slice and dice by. So, date, we might want to slice by day, week, month. And this is kind of almost always one of your dimensions is date. So you probably, if you've got a date field in there, you're going to need to have a calendar table, and we'll have a look at how to do that. If for our example here, we might have things like activity, right? So you have activity as one of your dimensions, you'll have location as one of your dimensions, and date, right? So those will be your kind of key ones on there. And then again, what you're doing is drawing this up just kind of on a whiteboard or just, again, offline. You're not being so constrained by the data. Here, you're trying to think about what we want to be able to, how do we want to represent our data? And then what we can do with this is cross-reference those against the questions and say, right, we want to be able to know, the latest finish date, or we want to know when things are going to be able to be complete. Will this kind of data model be able to answer those questions? So that's one thing we can do with this, so we can conceptually model the data. And this is your blueprint for how you're going to get it into Power BI. The second thing we can do is storyboarding, where we can start to just think about, actually, what's the story we want to be able to tell with this? And again, it's driven by the questions. But let's actually get into some of the data. So just out of interest, who's used Power BI before? Cool. Okay, wow. Okay, good. All right. So lots of pressure. You guys are familiar with it. Okay, so what we're going to do is start with bringing in some of this data. So we've got our P6 data and we've got our resource assignment. Now, actually, what we're doing for the initial bit of this, keep it simple. Let's just look at activities. Let's do our analysis on activities. So for our first bits of analysis that we're doing, we don't need to look at resource assignments, right? That can come later on down the line and we can bring that data in later. But for now, we just want to keep this simple. So we want to have activities and we want to have our dimensions, right? So we want to have our activities table that contain our activities, and then we want to have the things like that we can slice and dice by, such as activities, codes, and locations. So the first thing to do is if we go into edit queries, so start with Power BI blank, and one of the first things I actually do is always just create a parameter for folder path. Now the reason I do this is just because if you're bringing in data from your machine, or actually wherever you're bringing in data from, that might change, right? So you want to just set that location, and then you don't have to have it hard-coded in every single query. So what we're going to build here is different queries, but we want to just keep it generic as possible. So if I give this file to Poonam, and she doesn't have this location on her machine, then at least when she can just change this one parameter value, and then everything will still refresh, right? So what I'll do is let me just put that location where I've stored my files as folder path. So manage parameters, new parameter, and call it folder path. And obviously, if you're connected to a database, then you can have database in there. And actually, the idea is you can actually start to change your databases. So if you have a dev, test, production environments, you can then manage those through parameters. Obviously, we're keeping it quite simple today. So our source will that. So again, if it's a database, you could do SQL Server, for example. But what I'm going to do here is just connect to an Excel file or a series of Excel files. So I'm actually just going to connect to folder first. And it's going to say which folder path do you want to connect to. And I'm going to say parameter and folder path. Just structuring the data a little bit. And I'm going to go to transform data. So the idea of folder is actually really, if you've got all your files in the same folder, and you get, say, snapshots every month, it will combine all that data automatically. So if I do combine and transform data, I can't do that here because we've got different types of files in here. So I'm doing this really just to bring in the data. But you could, if they're all CSV files in the same folder, so you had different monthly snapshots, for example, and you click on combine and transform, it will just bring them all into one table. And then when you go and refresh that data, say next month, it will pick up the latest data in your snapshot and automatically refresh behind the scenes and then show your latest visuals. So this is where Power BI is starting to really see the automation benefits as well, rather than of processes, compared to Excel, where we used to have to write macros to kind of do this every month and bring in the new data and combine it. So let's just go to transform data. Right, so here, what I'm going to do is just call this kind of a staging table. So this is kind of your reference. Data in folder. And what I'll do, I'm going to right click on this query and disable load. So this determines whether it comes into your data models. But what I'm going to do is create a number of queries which I don't want to end up in my data model. They're just staging or referenced queries. So I'll disable load on that and it goes into italics. And what I can do then is actually reference that So now I've got then that staging table, and I've got some of this here. So now what I'm going to do is bring in my activities. And again, I'll disable load of this. And on this one, I'm going to click on reference on activities. And now it's brought in this data into here. Yep. And what I probably do actually need to do is go back and, no, that's fine actually on this one. Yeah, it's actually hard coded the path in here anyway, unhelpfully, so I can go back and change this to folder path. So it hasn't actually used what I wanted it to do in this case, but it's just depends on the files you bring in. But it's a good idea to have that anyway, just to show you the structure of how to do it. So we can go in here and we can see what it's doing. So if you haven't used Power Query before, what it's done is it's connected, it shows you your data at each step. So it's kind of like a macro. So here's where we can connect to data and apply all our transformations. But what we're able to do is apply the transformations through the UI, and then each time we'll create a step. So it will go in and it will create, say, source is the query before, which was data in folder, navigates to that particular file. And again, what we can do here, folder path equals, and we can actually just tweak the code that it's generated. So it's generated code in something called M. Path equals folder path. I might have done that wrong. I'll come back to this. I mean, what we could do here is just tweak this to be able to bring that in. I'll come back to that in a minute. And then what we could do is it shows you your data at each step. So promoting headers, and it did that automatically because it recognized your first row as headers, and it applied a change type step as well. So anytime we change things in here, we can see those steps appear here. So we can see our data at each stage. And also this is the code that it generates behind the scenes. So it's in a language called M, and we can go in and tweak these, or we could write our own if we really want to, but 80 to 90% of the time, what you need to be able to do, you'll be able to achieve through the UI. Right, okay, so we've got our activities, and what we want to be able to do then is, firstly, so let me put these two into a little group. And what we're going to do is to create a new group. So it's just a folder for our queries. So I'm going to create one called parameters and one called staging. So I'm going to put our parameter into here, into that parameters one. So move to group parameters, and I'm going to put these ones into staging. So now I'm going to just call this activities selected columns. So one of the first things I'm going to do is go in here, and again, actually I'll disable load on this. I'm going to go and select the columns I want. So I'll click on the table and click on choose columns. Now, again, this is a really important step because what it allows us to do is just slim down our data set to the stuff that we want to focus on. So we could go through these and say, actually, for what I'm analyzing, is what is relevant here. So activity ID and location codes are going to be, activity code and location codes are going to be relevant because we're going to link those to our two tables that we bring in. Actual finish date, we actually don't need float. So baseline finish date variance, object ID, I don't think we need. Percent complete. Project object ID. Actually, we will. These are useful for unique identifiers, but I'm actually going to show you. Ignore the fact that we have those for a minute because I'm going to show you how we can look at whether we've got duplicates anyway. Total float. Type we don't need. Extract date we don't need. Remaining and finish date we don't need. So I think that's kind of, we're looking at what we need in our data. We're going to slim this down just to what we kind of need. And we've got then our fields there. And it's obviously picked up the date types as well. Sometimes it doesn't get those right and you get errors when you try and load your data. So sometimes what you're better off doing is just applying all your transformations and then just going in and setting the data types yourself almost at the end, just to make sure that it doesn't have any conversion errors and things like that. Because it takes a stab at it, and then sometimes if you've got data that doesn't conform to that, you'll just get errors. So it's good for you to be able to set those. Right, so now we've got our selected columns. So again, I'm going to kind of reference this again. And what I'm going to do here is start to just think about what we want to look at for each of the data. So When I said this data was messy, there's a few ways we could identify the fact that this data isn't necessarily giving us what we want. And one of those might be actually duplicates, or is it at the right granularity of data? So if we look here, what we might expect is that we have, for each data date, for each project, for each activity, and maybe location code and activity code on those, we only have one row per data date. Right? We would expect to see the same activity appear multiple times for each data date. Right? And that's sometimes something we can check, because actually it's a good idea as to whether this data is good quality or not. So one of the things we could potentially look at is then say, okay, so say we selected these columns. So let's have a look at for a start and see actually whether we've got any duplicates in the table as a whole. So actually whether any of these rows across all the columns is duplicated. So we could do keep duplicates. So we go to keep rows, keep duplicates. And this might take a little while because it's a bit of a data set. And actually we can see that we actually do have duplicates across the data sets, right? Let me just select all the columns. You can see that going at the bottom. And what we'll see is we do have some duplicates. So where we've got duplicates across all the rows, we could potentially just remove them, because we don't need duplicates if we don't need the same row represented more than once. So we can see here we've got duplicates on those, and they're all the same across every single column. So we can see the top two, for example, are all the same across every single one. So actually, we know that we've got some duplicates. We can just go in and just say remove duplicates. Great. So at least that's got rid of duplicate rows within the same data set. But again, that doesn't necessarily mean that actually we haven't got duplicates within what we're interested in. So if we actually keep now data date up to there and maybe name, and now we look at keep duplicates, we're going to see actually whether we've got duplicates within that set. So actually we might have, for a given data date, we might have for a given activity ID, a location and activity, maybe we have two completion dates, two actual dates, or two baseline finish dates. And again, that might be problematic, because that's not necessarily, how do we know which one to pick? We only want one per each of those. So we can see now actually if it's filtered onto this. So for example, in this top row, we've got, it's the same, for the same data date, for the same project ID, same activity, same location code, same activity code, same name. So they've got the same actual finish date, which is null, but they've got different baseline finish dates. So we've got two different baseline finish dates for the same activity. And again, we've got null and 0 on finish date on there. And we've got the same early finish date, same late finish date. So we can see actually that, for example, is an indication where our data might not be best quality, because it means we've got some duplicates across that activity. So what we could do, we could remove duplicates, and that would be quite a crude way of doing it, because what it will do is it will just get rid of the first row. It will pick up the first one and get rid of anything else. So what a more intelligent way of doing it might be is to actually use the group data functionality. So what I'll do, let me get rid of that step. If we want to get rid of a step, that was just a test to see if we've got duplicates. We don't necessarily want to apply that step to our data, so we could just delete it by clicking on the cross. So here what we can do then is look at the group by functionality. So we select the columns that we want to group by, and let's put them all in there. So we'll group our data by this. So if anyone's worked with SQL databases, it's the same idea of grouping your data. And now then we group by all of our non-numerical data columns. And then we want to say, right, so actually, maybe we apply min or maximum. So if we've got two finish dates, let's apply the maximum. So if we've got a null and an actual one populated, we want to take the one populated. If we've got two that are populated, let's just take the latest one. So let's just say here, we've got latest finish date. And let's do actual finish date. I'm actually going to call them the same name. It doesn't matter if it's the same name. It just keeps the actual finish date is the max of actual finish date. And we can go into these. Again, we'll do max of baseline finish date. I think if we did actually do an object ID, it would be unique, right? Should be. But that's not always the case. You don't always sometimes have a unique identifier in there. So the idea of this is to look at where we've got finish date variance, and then we've got early finish date. Actually, what do we do for early finish date? Let's do the min. So if we have 2 populated, let's take the earliest one. And late finish date, max again. Cool, have I covered all those? So now what that will do is it will group by all of those fields and make sure there's 1 row per each of those. So if we do have more than 1 row in any of those, it will take the maximum of those for each of those dates, or minimum for in the case of early, and give us 1 row per that. So now we've got our data in hopefully the right level of granularity. So we've got 1 row per each of these, per data date, project, activity, location, activity code. The next, and what we'll do once we've done this, we'll just check that it's given us the right data. Cool. So now we can do activities grouped. And what we can do is also, we can see actual finish date. It's looked at the first 200 rows or so, and it's picked out there are a lot of nulls in there, so it's not picked up as a date field. And we can see that by the ABC on there. So one of the things we might need to do, whereas in baseline finish date, it's picked up that there's dates in there, so it's put it as a date type. So we can go in and change that to date, and it will hopefully pick up the nulls and just pass them in as nulls, and then where it's got a date, it will actually recognize it as a date. And this is going to be important. Great, so that's picked up to the date now. So now let's just do a quick check. So let's just select our non-numerical ones and go to keep duplicates. And hopefully now we should have duplicates across these. So we should have activities for each data date. Obviously they'll be repeated for data dates because the same activity will appear multiple times, but it shouldn't be repeated within a data date. And we can check that. So the other thing I wanted to potentially do with this data is start to look at how we can add some calculations or some kind of metadata to it that we want to be able to slice and dice by. So there was a field in here called status. So it was completed, not started, or I can't remember which one it was. Completed, not started. I think it was. There's only 2 or 3 values in there. But what we actually want to do potentially is make that a little bit richer. Because if we can start to categorize our data at the most granular level we can, then that will give us a much richer slice and dice capability within our report. So what I'll do is open up what I did earlier with this. So what we'll do, let's reference this again, and again disable load on it. So this is 4. So CSV files can be, big CSV files can take a bit of time to work in the query editor. That's just one thing to kind of be aware of. I mean, working with databases is much faster, generally. What the CSVs has to do is it brings it all into memory. With databases, it can actually pass some of that querying back to the database and perform it there, where it will be much faster than running it on your local machine. So what I wanted to do, actually, what I'll do, let me open up an example I've done earlier, because this will then actually give us an example of how we can what I'll do is I'll show you, I'm conscious of time, I'll show you what some of these things look like. So this is where we started with. And then what I did with this then is say, okay, so we've got our dates here, actual finish date, baseline, early finish, later finish. I said, actually, let's see how long we've got till the finish date from the data date. So let's look at the time between the data date and the baseline finish date, so we can see whether it's overdue, whether it's due in the next few months, or whether it's and if it's been completed, then we could do this. So all I had to do with that is do add column, date, age, and what it's done is, what it will do then is give us by default from today, right? So we'll say date from, date time local now, baseline finish date. So we could go in and tweak this. So we can say, actually, we want to do it from the data date rather than from today, right? Because today's irrelevant. This data's 2 years old. I'll say. So did that, and I'll just go through these steps rather than showing them now. So inserted the age. So duration.days data date minus baseline finish date, and it's added it as a new column. I then went in and divided it by 30 to give me the months, and then added in a column that said if it's null, then it's not planned. Otherwise, look at the age from data date months, and we can add this through conditional column. So you can do it through the UI as well. And it's basically said if it's less than minus 12, then it's due in 1 to 3 years. So it's given it a category. So we've got in here, so we've got age from data date in days, done that in months, and then just done a field that gives us 3 to 6 months overdue, overdue up to 1 month, overdue in 3 months. And then what we can start to do is analyze these by saying, okay, let's look at our overdue ones. All right, fine. We know we've got 300 activities that are overdue, as at that date, or as at the latest data date. Right, how many of those are actually overdue by like 6 months? Or how many of those are overdue by a year? Because that's going to give us more detail as to what we can really analyze by. So it's going to give us that richer slice of dice. So we've done that for the due and overdue. Gone and done exactly the same thing from actual date. So take the actual finish date less the baseline finish date. So that will tell you whether it's been completed late or not. So then again, we've got those categorizations there. So we go to add column, conditional column. If it's less than this value, then it's this. Then we give it an attribute value. So less than 36, completed early by 3 years, and got up to 3 months completed late. Yep. Otherwise, we just put NA. So now we've got our due or overdue category, and then we pick one of these. So if its actual finish date is null, then we take due or overdue. So it's either due or it's overdue. Otherwise, it's completed, but then we have completed late or completed early or whatever it is. So we pick one of those, and then that's what we've got left. So now we've got our activity status, where we've got our 3 that are there. Yep. Okay. What I did then is brought in. So now we've got then our activities. So this is now our activities table. So we've got data date, activity ID, location code, activity code name, actual finish date, baseline finish, early finish, late finish, the variance, and then the status. And what I did with the status is said, okay, we brought in our statuses. So what I did also, if you remember on here, we had reference data. Yep. So I brought in the reference data. And reference data contains the 3 things we've got there. Location codes, so it's just a list of our location codes, activity codes, and statuses. So statuses I just produced manually in Excel and just brought it in. So it's all our possible statuses. We've given it an order. So you can create, bear in mind, you can create your own fields for this. So you can just create something in Excel that has all your possible values, give it a sort order, because it will help with your sorting. And maybe if you want to do some other attributes of it, then put those in those files as well. So this is where what you really want to start thinking of your data is actually what can I have in these tables that are descriptive. So all your descriptive tables are linked to separately. Do you remember in that data model we had our facts, and then we had all of our dimensions coming out as branches, and those were all your descriptive tables. So where you don't have them, create your own. So this is what we've done here. We wanted to actually get a richer slice and dice capability than we had from the data itself. So we created a calculator column that gave us these possible values, and then we're also categorizing them. Are they completed, due, overdue, or not planned? So this is now a much better status view than we would have got just using the data as it came. So now we've got then our dimensions. So we've got activity codes, location codes, statuses, and dates. And statuses can link. You can link on this text field. So I can link the status to status, but I've also got a status ID here. And actually what I might want to do for performance reasons and for neatness is actually link it on this key. So what I did back in activities is I went into source, I merged queries, so go into home, merge queries, and merged it with, and said actually I want to join, so this is like a join in SQL. I want to join activity status with my statuses table on activity status, and then I want to bring in the status ID. So now it brings it in on status ID and remove columns. So what we've got here is then our activity status, and we've got these tables here. So when you click on close and apply, what you'll end up with is a data model that looks, this is called the star schema. So it looks very much like that conceptual model that we came up with. So we have our numerical tables here in the middle, and then we have a relationship to all of our descriptive tables. So date, by the way, so I forgot to show date. Date tables, you can just use any script. So I'll put one up on here. This is one I used for creating it. So this is what I created in the query editor. So to show you what you do there, you do get data, blank query, and then paste in the code. And you can paste that into the blank query in here, or you can go to advanced editor to see it in a window. Yep, so paste it in. So this will just give you all the dates between your two date ranges. So here I've done it between 2016 for 3 years. And then once you do that in, you'll have a table, ready-made table, and you can reuse this obviously for every report that you produce. You can do it in here, or you can do it in DAX, and then that gives you just some dates and all the attributes of your dates. Yep, so that's dates was one of them. Let me just disable load on that. And so now we've got our date table, and then we've got activity codes, location codes, and statuses. And each of these have a one-to-many relationship with these. So the idea is that there's one value in here, so each of these is unique. So activity code, statuses, location code should contain one row per each of those, per location code, per activity code, per status, and there's one row per date. That's how we designed our date table. And then it links back into here. So that's what this one and the star mean, one to many. This is how your data model should generally be built. You can have many to many, but I would strongly recommend against doing that for a number of reasons. This is the way that we're supposed to build data models. And building this data model right will be really helpful for your analysis. Once I did that, I just started to then bring into the canvas. So now we've got a data model, and we've got, I brought in a background by going to page background and just browsing to one that I had. So this is one for A14. I mean, you can come up with something that you can bring in there. You can also bring in color themes. So if you want to do a particular color theme and you want to have a different set of colors, you can do that and import themes in here. So insert themes view, I think is themes, yeah. Themes, and we can import theme there. So what we need to then start to do is just think about how we can show some basic measures. So we can start to do some simple calculations. So the first one we could do is, the first thing I did actually was do baseline finish date. So now we've got, this is the date that we're going to calculate our latest finish date. So this is the latest date that we've got. So bear in mind we've got, this is just max. So we go to modeling, new measure, and we say max of activities baseline finish date. So it's the latest date. So if we just drag this, so we can see it's a measure with a little calculator icon. If we just drag it into here and show it as a card, then we can see that it's 19th of January 2022. Okay, so that's useful to know. What we could also do though is start to see it by section, and we don't need to create another measure. So we can say what section are we planning, or what date are we planning to complete each section on. So this is, again, keeping it really, really simple. We can just bring in from here, from location codes, and bring in section, and actually just show it as a table. So we've got section, and we've got our baseline finish date. So now we can see total, obviously means for the project overall, but now we can see which date each of our sections are planned to be completed, right? So without actually having to do any kind of analysis or anything, actually that's quite useful just to be able to see. Now what we can start to do is start to think about, well, actually, how could we show the percentage complete of each section, or how could we show things like that? So one of the things I did here was just say, let's first of all just create that unique ID. And I think object ID, actually, when I look back at the data, was unique, but it might not be in your data. So activities, activity code, activity ID, and location code. So that was our unique set. And then we can just create a measure to say the number of activities is going to be in here. So we can do now in here, modeling, new measure. So now we want to do number of activities. Oh, sorry, that's got really small for some reason. Equals, and what we want to do here is distinct count of object ID. So now this is going to give us the number of activities that we've got. And bear in mind, this is by data date. So this is overall. So overall, across all the data dates, we've got 22,000 activities. Yep. And what we could also do is say we could start to apply some filters in here. So again, a little bit out of scope of kind of where we could get to with this today. But what we can start to do is say, actually, we want to look at a filtered view of that. So if we do number of activities as at latest data date, and then the way I tend to write these is you can use something called variables in DAX. So it's just a way for you to be able to write something like to set a value like we can in anything else, and it just makes your code a bit easier. So I'm going to create a variable called latest data date. And again, we can just do max of activities. Activities data date. So now we're going to say that's your latest data date. And actually, if we wanted to make sure that that wasn't filtered, we could just put in all activities. Yep. And that will just make sure that we're not filtering anything. Ideally, we should do it on all data dates to make it faster. But here, and then what we can do is define a little filter. So we can say, actually, do you know what? Let's just write this up. So we'll do calculate table date filter. So this calculate table allows us to pass in a filter condition. Yep. So we're just going to do dates. And date equals latest data date. So I'm just going to create a little filter condition for that. And then what I want to return is I want to do calculate. So calculate allows you to be able to calculate any measure. So here we want to do number of activities. And then you want to give it a little filter expression to apply it by. So here I can now just pass in my date filter. So I want to calculate the number of activities where the date is at the latest data date. Right, so now this is going to give me activities as at the latest data date. If your data was completely clean, actually you'd have the values the same, because your distinct number of activities would be, it depends if stuff drops off. But if you don't have anything dropping off, then it'd be the same. And there we've got 12K. So as at the latest data date, we've got those. And then total number of activities, the latest data date is there. And then obviously what we can start to do is look at those that are completed, i.e. that have an actual finish date. So where the actual finish date's not blank, and do one over the other, and it gives you your percentage complete. So that's as far as I think we can get to today, because we've got things on there. So other places we can take this, we can start to look at percentage complete over time, so start to look at those S-curves. We can start to look at what our projected finish state might be. And that would be starting to answer that question. And the way I did this in the previous challenge, I'm happy to show anyone if you want to see it, is I looked at activity dates and looked at by activity what the average delay was per activity across all the data dates, and then applied that to the finish date of each activity to say this is your baseline finish date. On average for this activity, this has been the delay, so I'm going to assume that delay for that activity, and then apply that, and then look at the later state you've got then. So then you can start to say, well, actually, how likely you're likely to finish this on time. So I hope that was hopefully interesting. So as I say, the focus of this is really on how you can start to work with the data, start to understand what you want to get out of it, start to look at it look at the data quality in the query editor and clean up some of that data, like remove duplicates if you need to, and then model it in the right way and start to do some of these measures. And hopefully that's enough to get you started. If you get to this stage and you want to know more, come and grab me. I'll be around all day, sitting with the 2B table. So yeah, if you want any help with this, let me know. Cool. Thanks, guys.